Hello everyone, Bill Nye here, and today, I'm excited to share some truly fascinating news about our planet's atmosphere. As we approach the end of 2025, something extraordinary is unfolding high above us, something that could affect millions of people across the globe. The polar vortex is collapsing, an event that could make this December one for the history books, especially in North America. This isn't just a minor shift, it's a dramatic change in the way cold air moves around our planet. This isn't your average winter forecast. We're talking about a potential for record-breaking cold, intense snowstorms, and weather patterns that could disrupt travel, energy use, and even daily routines. It's a rare top-down signal from the stratosphere, about 10 to 50 kilometers above us. The stratosphere is like the command center for our weather, and when it sends a signal, we need to pay attention. Imagine a message sent from the top floor of a skyscraper, warning us to brace for a prolonged blast of Arctic air. This message travels downward, eventually reaching the surface and changing the way we experience winter. What's remarkable is the timing. This atmospheric shakeup is happening in November, almost unheard of. Usually these events occur much later in the season, so this early start is truly exceptional. The early start means the atmosphere has more time to react, leading to a stronger, more predictable impact on our winter weather. Meteorologists are already seeing signs that this could be one of the most significant weather events in recent memory. We're about to see a ripple effect that will shape weather patterns for weeks, possibly even months. The changes won't just be local, they'll be felt across continents, affecting everything from agriculture to transportation. So get your winter coats ready. We're diving into the science behind this rare phenomenon, exploring how it could impact your community and what it means for your holiday season. Let's get started. So, what exactly is the polar vortex, and why does it matter so much to our weather? It's not a single storm, but rather a massive, persistent area of cold, low-pressure air that spins high above the Arctic, circling the pole like a crown of icy wind. This swirling system is a fundamental part of our planet's climate engine, quietly shaping the seasons from above. The polar night jet stream acts like a powerful invisible fence, wrapping tightly around the Arctic and keeping this frigid air locked over the pole, away from the rest of the world. In a typical winter, the vortex is strong and stable, spinning in a nearly perfect circle. The cold stays put, trapped far to the north, and the Arctic endures its long, dark, frozen season. Down here in the mid-latitudes, we get winter, but it's usually moderate, cold, but not bone-chilling. Our weather is influenced, but not dominated, by the Arctic's deep freeze. You can think of the vortex as a well-guarded refrigerator, with the coldest air sealed away behind a tightly shut door. As long as the door stays closed, the chill remains contained. The strength of this polar fence depends on the temperature difference between the pole and the equator. The bigger the contrast, the stronger the vortex. When the Arctic is plunged into darkness and temperatures drop to their lowest, the jet stream tightens its grip, locking in the chill and keeping the cold bottled up. This is known as a positive phase of the Arctic oscillation. During this phase, winters in temperate regions are often milder, while the Arctic experiences its harshest, most relentless cold. But sometimes, the vortex weakens. It can wobble, stretch, or even split apart, and the fence that once held the cold in place starts to break down. When this happens, frigid Arctic air escapes, plunging southward and bringing sudden extreme cold snaps to places that aren't used to such icy blasts. Instead of a neat, tight circle, the vortex becomes distorted and stretched, like a lopsided spinning top wobbling out of control. The result? It's the atmospheric equivalent of leaving the refrigerator door wide open. Cold air spills out, and the chill spreads far beyond its usual boundaries. That's when things get interesting, and the weather can turn wild and unpredictable, reminding us just how connected we are to the frozen crown of our planet. The big disruptor? A sudden stratospheric warming, or SSW. Despite the name, this rapid heating in the stratosphere triggers intense cold at the surface. In days, temperatures over the North Pole can jump by tens of degrees Celsius. Powerful atmospheric waves from below break in the stratosphere, releasing energy and heating things up fast. This throws the polar vortex into chaos, breaking down its stable spin. What's historic about November 2025 is the timing. SSWs usually happen in January or February, not November. Since 1958, this has only happened twice before. An early SSW means a longer, deeper impact on winter weather, setting the pattern for December. As the SSW peaks, the polar night jet stream slows or even reverses, signaling the collapse of the vortex. The Arctic gate is open, cold air is ready to surge south. It might seem counterintuitive, but when the upper layers of our atmosphere, the stratosphere, warm up dramatically, it actually sets the stage for some of the coldest weather we experience down below. This surprising relationship is at the heart of some of winter's most extreme cold snaps. The phenomenon is called a sudden stratospheric warming, or SSW. When it happens, it weakens the polar vortex, a powerful spinning current of cold air that usually stays locked around the Arctic. The jet stream, which acts like a fence keeping that cold air contained, starts to break down. As the vortex splits apart, smaller pockets of frigid air are set free, wandering far from their polar home and plunging southward over continents like North America and Eurasia. Think of it like a spinning bucket of water. When the spin slows, the water sloshes and spills out. In this case, the water is bitterly cold Arctic air. That's the cold air pouring out, flooding southward and transforming the weather for millions of people. This dramatic process is known as an atmosphere-to-surface connection. This year, meteorologists predict that connection will be especially strong, making the impacts even more intense. The jet stream below becomes wavy and distorted, with deep troughs that act like highways, channeling Arctic air much farther south than usual. Meanwhile, ridges in the jet stream allow milder air to surge northward in other regions, creating dramatic temperature contrasts across the globe. So, a polar vortex collapse doesn't freeze the entire planet. Instead, it rearranges the map, sending deep freezes to some areas, while others experience unusual warmth. The southward surge of this cold air is known as an Arctic outbreak, or a polar plunge, and it can happen with astonishing speed. This dense, heavy air often brings clear skies, but also bone-chilling temperatures that can break records and test our endurance. When this frigid air sweeps over moisture sources like the Great Lakes, it can trigger massive snowstorms, sometimes dumping feet of snow in just a day or two. The collapse of the polar vortex essentially opens the floodgates, allowing the coldest air on Earth to invade regions that are usually much milder in winter. That's why these events are so significant. They can reshape winter weather patterns, disrupt daily life, and remind us just how powerful the forces above us really are. Why are scientists so confident about this cold spell? Because the SSW isn't acting alone. Two other climate drivers are syncing up: a weak La Niña and a specific phase of the Madden-Julian Oscillation, or MJO. The SSW is the main trigger, breaking down the polar vortex. La Niña, with cooler Pacific waters, sets the stage for cold air to move south into North America. The MJO, a pulse of tropical rainfall and wind, is entering Phase 6, historically linked to steering Arctic air toward North America. The SSW opens the Arctic floodgates. La Niña creates a favorable path. The MJO directs the flow right at the continent. This rare alignment gives forecasters high confidence in a major cold wave. It's unusual for all three to sync up, making December 2025 especially memorable. It's a powerful example of how global climate systems connect. The result, a perfect storm for a deep freeze. With all these drivers aligned, North America is the bullseye for this Arctic outbreak. A blocking high over the Beaufort Sea and Greenland will steer the cold air south, locking it over Canada and the northern U.S. regions like the Great Lakes, Northern Plains, Quebec, and Ontario will see persistent, below-normal temperatures. This isn't just a cold snap, it's a deep freeze that will define December. The negative phase of the Arctic oscillation is classic for a polar vortex disruption. Expect significant snowfall, especially lake-effect snow near the Great Lakes. For many, it could be a very white holiday season. Prepare now, winter is coming in force. While North America braces for a deep freeze, Europe and the southern US will see a different story. The same wavy jet stream that brings cold to North America creates a ridge of high pressure elsewhere. Europe, shielded by the blocking high, will likely have a milder December after a brief, cold snap. The southern US, under La Niña's influence, will be warmer and drier than usual. The jet stream keeps Arctic air bottled up north, while the south enjoys mild, sunny weather. This contrast shows how interconnected our weather is. Cold in one place means warmth in another. A single stratospheric event can have opposite effects depending on where you are. So, while the north shivers, the south and Europe enjoy a milder December. The SSW's influence will dominate December, locking in cold and snow for North America. This isn't a brief chill, it's a regime that will last through the holidays. But the SSW's grip won't last forever. As we move into January, its energy fades, and the polar vortex tries to recover. La Niña will become the main driver, bringing more variable and unpredictable weather. The second half of winter could see rapid warm-ups, sudden cold snaps, and big swings. December's cold is set, but January and February are wild cards. The atmosphere always has surprises in store. We're on the verge of a remarkable winter, thanks to a rare event high above us. The early polar vortex collapse, triggered by a historic SSW, sets the stage for a December to remember. North America faces deep cold and significant snow, while Europe and the southern US stay mild. The alignment of SSW, La Niña, and the MJO is a textbook case of climate systems working together. This is a chance to appreciate the science behind our weather, and to be prepared. As we move into the uncertain months ahead, let's keep watching and learning. Bundle up, stay safe, and enjoy the spectacle. Thanks for joining me. Here's to a very cool winter.